Hello students, today we will discuss about synthesis of nanomaterials, in particular photolithography. So, nanostructures can be fabricated by physical techniques and they are derived mainly from the techniques for the fabrication of microstructure for semiconductor industry. So already lithographic technique was available for fabricating structures in the micrometer dimension, which is familiar for the semiconductor industry like IC chips and all. So the same technique was employed for devising uh, designs or features in the nanometer range. So the basic steps involved are will be first coating a resist onto a base material, and then we'll expose it through a mask. So the exposure can be due to a light or a particle or a probe, and then it can be developed in two ways, either positive development or negative development, which means this particular structure will be dipped in a developing solution. So in the positive case, where the exposure is made, that exposed region is dissolved off. Okay, so what will happen? It will then immersed in a etching solution. So etching solution will etch out the region which is exposed to the solution. That means the region which are avoid of resist layer. Resist ഇല്ലാത്ത ഭാഗത്താണ് etching happens. And finally, what is the process done? Stripping is done. So what happens? Whatever be the shape of the mask, as such is imprinted onto the base substrate, and hence such a development is called positive development. In the negative case, here you can see the exposed region is insoluble while the unexposed region is dissolved off in the developing solution. So negative means the unexposed region is dissolved. So what happens? Again it is immersed in etching solution, and hence the region which is devoid of resist is etched out, and finally you will strip out the resist layer that is remaining. So you get just the opposite of the mask structure. Mask in the pattern, the opposite is obtained in the substrate, base substrate, and hence it is called a negative kind of development. So these are the basic steps in the lithographic technique. So it was also called photo engraving because we used to transfer a pattern into the reactive polymer film using visible light, and hence the name photo engraving. Engraving എന്ന് പറഞ്ഞാൽ transferring a pattern onto a substrate. So photo engraving means we are engraving with the help of light. So subsequently, this can be used to replicate the pattern into the substrate. So that is how the technique was involved in the semiconductor industry also. So the type of interaction used to modify the resist can classify the lithography. So as we have mentioned earlier in a previous section, you can modify the resist using the incidence of electromagnetic radiation. Then such a lithography is called optical lithography. Or you can modify the pattern using particles like electron beams, ion beams, and hence the name particle lithography. So that is based on what is used to modify the resist. So the way, now based on the way the patterns are returned written on the resist, you have parallel writing method and the sequential writing method. So in parallel writing method, the whole pattern is made simultaneously using a mask which dictates the features to be reproduced. That is, this is analogous to the case where we are making a projection of a transparency. That is, if you project your slide onto the wall or onto the screen, what are we doing? We are projecting the slide as such. So that is called parallel writing. If you are making the pattern, the entire pattern onto the surface, then it is called parallel writing method. And it is faster, only single stage is involved. And what you do is, we'll first make a mask and then duplicate the mask onto the resist surface. In the case of sequential writing method, the patterns are written point by point, and this is what is happening in particle beam lithography, where sequential writing is preferred. That is, pattern features are formed using a basic tool. This is like if you try to write matter onto a paper, what do? We'll write one letter by letter, right? So that is a sequential way of writing. So similarly, a sequential writing in synthesis method means you are creating pattern one by one onto the point of each point of the resist layer. And it will be much slower because it requires one by one, multiple steps are involved to complete the pattern formation, so it is slower technique. And there is no need for the mask also, as we are controlling the movement. It just need to control the movement. You don't require a mask to give a pattern. So the next one is, let's see the features of photolithography technique. So in photolithography, what is used? Visible light is used, and hence the name photolithography. Earlier we have mentioned only optical lithography. So in optical lithography, it could be, let me write it out. In optical lithography, you could have a visible light to expose the resist layer, or you could have UV light to expose the resist layer, or you can also have X-rays are also used to expose the layer. Okay, and if it is visible light that is used for lithographic technique, then only we call such a lithography as photolithography. So first, what you do is that we'll produce a mask carrying the requisite pattern information, so that the size will be according to the nano size features, and subsequently we'll transfer the pattern using some optical technique onto a photoactive ആയിട്ടുള്ള പോളിമറിലേക്കാണ് pattern transfer ചെയ്യുന്നത്, or which is also called photoresist. Photoactive polymer is also called photoresist. So there are two basic techniques used in photolithography. One is shadow printing, other is called projection printing. So in shadow printing, you could have contact printing as well as proximity printing. There is a spelling mistake over here. And in projection printing, you will be projecting the feature onto the resist layer using some optical system. So as the name indicates, in contact printing, the mask is kept in contact with the photoresist. That is, there is zero spacing between the mask and the photoresist. While in the case of proximity printing, proximity means closer. Mask is only closer to the photoresist layer. It is not kept in contact, While in the case of projection printing, the pattern or the mask is projected onto the photoresist layer using an optical system or a lens. So as we mentioned, these are the basic steps in lithography. So first, initially what you do is, we'll coat a resist material over some base substrate and then expose in an image wise fashion through a mask such that the light strikes the selected area in the resist material. So only the openings will allow the light to fall on the photoresist. So either the exposed region could be dissolved in the dielectric solution, or exposed region is undissolved in the dielectric solution. So in that way you will get two kind of dielectric techniques. So in the positive kind of technique, exposed areas are soluble in dielectric solvent, while in negative, exposed areas are less soluble. And then it is dipped in a etching solution. So it will produce a 3D relief image in the resist material. That is the replication of the opaque and transparent areas of the mask. And resists that remain following the imaging and developing process are used to mask the underlying substrate for subsequent etching. So whatever resist layer remains will guard off the underlying base layer from etching off. That is the relevance. Okay, so only those regions which are exposed, those regions of base which are exposed, will undergo etching. So finally the resist layer is stripped off and you will get the pattern as such. So it could be a positive pattern transfer or a negative pattern transfer. Now there are two things to be checked during photolithography. The first thing that could affect the structure features are diffraction. Now, as you know, if you consider the incident light, it will have a higher intensity towards the center, while it is a Gaussian kind of intensity profile. So what will happen? We would expect it to have a perfect vertical nature, but actually it would be a pattern like this. So that will set the limit of the maximum resolution or minimum size of the individual element formed using photolithography. So the image of a perfectly delineated, that means exactly vertical edge, become blurred or diffused at the resist surface. So etheric density is in a changing way. So what you get will be a pattern will be of a curved nature rather than a exactly vertical pattern. So that is the problem involved or faced in the photolithography. So theoretical resolution capability is discussed on the basis of a formula where you can see 2b is the grating period, that is the separation between the two features on the mask, equals 3 into square root of lambda, which is the wavelength of light used, s, which is the gap between the mask and the photoresist, and d is the photoresist thickness divided by 2. So for minimum feature you should have very small spacing and very small thickness of the photoresist layer on the base. So now let's have a comparison between different kinds of mode. The one is contact mode, other is proximity mode, and the other is last one is a projection printing mode. So in contact mode, as we mentioned, the distance or the gap between the mask and the photoresist layer will be 0. That means mask and wafer are in intimate contact. So the transfer efficiency or accuracy is 100% because it is exactly resting on the mask is exactly resting on the photoresist. So there is no shadow region formation, and hence the water light is falling on, it will be exactly falling onto the surface, and exactly it will be guarded off also according to the mask structure. So it will provide higher resolution, but it is seldom achieved. The reason is there could be dust on the substrate. So the substrate over which we are keeping the mask, it may contain the dust. So what will cause the dust? How the dust will affect the surface feature? Yeah, mask will be not in proper contact. So the alignment is an issue when you keep the or when you try in contact mode. So the mechanical action required to force the mask against the resist creates a debris which may damage both mask and the substrate. So when you try to keep the mask over the photoresist in contact, some amount of force has to be applied to keep it closer. So that will allow damage to both the mask as well as the substrate. That is another problem involved. Now let us see about proximity. So in proximity, that means the mask is closer to the gap. There is a very small gap between mask and the wafer, closer to the film, photoresist film. So the problem of dust and non-uniformity in the surface will not affect the pattern formation, but there is a problem. Increasing the gap will degrade the resolution of the features, because if you have a substrate like this over which a photoresist coating is there, and if you have a mask over it, if the mask is very much closer, say these are the structures of the mask. So what will happen? The light that is falling will be falling on the surface, or passing through the voids will be falling on the surface exactly vertically. But as we increase the distance between the substrate and the mask, as the gap increases, that is, if I make it to this much level, what happens? Let me draw again. So you have a substrate over which a photopolymer film is coated, and there is a mask over here. So what will happen? If the mask is at a very high distance farther from the photoresist film, the light incident will be making a direction like this. Okay, so that is called, there is a entry of light rays into the shadow region. This is supposed to be the shadow region. But shadow region lekkulla entry varum. Okay, so that will expand the penumbral region. Penumbral region എന്ന് പറഞ്ഞാൽ ആ ഒരു ലൈറ്റർ ആയിട്ടുള്ള ഷെയ്ഡ് വരുന്ന റീജിയൻ, ഹൈ ഇൻറ്റൻസിറ്റിയേക്കാളും ലൈറ്റർ ആയിട്ട് വരുന്ന ഷെയ്ഡ്. So if this is closer, then the penumbral region will be very much less. So increasing the gap between the mask and the wafer will expand the penumbral region, so that will affect how the patterns are transferred. And there is also a difficulty in controlling the gap, കാരണം the gap at one end has to be the same at the other end also. So we need to ensure proper gap is maintained, constant gap is maintained across the sample. So that is also a difficult situation. And it also requires a high degree of planarity in both mask and wafer, otherwise the gap will not be a constant. And it is not at all a problem here it has no problem with absorption or chromatic aberration that is seen in the optical system. That we will see with the next technique, that is in projection printing. What is done is we make use of optical lenses and mirrors and to project onto the mask features onto the substrate. So there are lots of lenses are involved, so that will increase the absorption of intensity of light by the lenses and the optical elements, and hence it may undergo chromatic aberration. Chromatic means depending upon the wavelength of the light that is incident, the amount of bending it undergoes will be different. That is what you meant by chrome. Chrome means color or wavelength related. So if the bending is different, the focusing for red will be different from focusing for violet. So as we give a white light, it will have 7 colors, so different focusing will happen for different colors. So that problem is involved with the projection printing, while that chromatic aberration problem or absorption of intensity is not there when you consider a proximity printing. Okay, and it also has lower resolution than the shadow printing techniques. Shadow printing techniques are contact mode and proximity mode are the shadow printing technique. Compared to the shadow printing technique, this projection printing has lower resolution. And because of lens imperfections and diffraction, it leads to the lower resolution. So in projection lithography, the resolution, which means the minimum size that could be featured onto the surface of the substrate, that minimum surface will depend upon wavelength as well as the numerical aperture of the system. So lambda is the wavelength that is used and Na is the numerical aperture of the optical system. That will depend upon how much the cone angle of the light beam. So this is the cone angle of the light beam, that means angle between the extreme rays in the light beam. So from the equation it is seen that for better resolution, what should be the lambda is in the numerator, so R must be less, which means lambda must be less, or depth of focus must be more, or depth of focus must be or resolution must be less. That means numerical aperture has to be large enough. Okay, so the diffraction resists any conventional imaging process to a resolution of approximately lambda by 2. So because the photo lithography, so you have to remember whatever be the wavelength that is used, അതിൻ്റെ half ആയിരിക്കും the resolution, the minimum size that could be obtained. So for a visible light, the wavelength is of the range 400 to 700 nanometer. So the minimum wavelength possible is 400. So the half of that means we could have a size, features of size 200 nanometer. Okay, that is mentioned here. The conventional photolithography, that is using visible light, can fabricate features of 200 nanometer or above. Okay, so we'll end up with this. Okay, thank you.